Hello friends. So our today's question of the day is lucky number in a matrix. So we are given m cross n matrix of distinct elements. Okay, we have to return all the lucky number in a matrix in any order. Okay, so we are given an m cross n matrix of distinct number. We have to return all the lucky numbers. Now what lucky numbers are? So a lucky number is an element of the matrix such that it is minimum element in its row and maximum in its column. Okay, so the definition for lucky number is given as it is an element in a matrix such that it is minimum element in its row and maximum in its column. Okay, so like if we look at this example, okay, so for this for first row the minimum number is 1. Okay, whether it is greater in its column, no. Okay, then we have 10, so 10 is not smaller in this row. Then in this case we check for 3. 3 is smaller in this row, so whether it is greater in its column, no, it is not. Okay, then we consider 12. So 12 is smaller in its row and 12 is greater in its column, so yes, we can say 12 is a lucky number. So what they were saying, what element they are considering as lucky number, a number which is smaller in its row. Like in this row we can see that 12 is smaller in this row, smallest element in this row, and then it is that element is greater in its column. Okay, so if we see this column, okay, so it is greater in its column, so we can say 12 is smaller in its row, smallest element in its row, and it is greatest element in its column, so we can say yes, the condition for being lucky number is satisfied and this is a lucky number. Okay, so basically we have to find all the lucky numbers from a matrix of m cross n. Okay, so now let's see how we can do this. Like we are pretty much good with the question. Now let's see how we can provide the solution, or we can have a solution for this. Okay, so now let's consider, like in this, if we consider this, so the smallest number in first row is 1. Okay, if we write them here, the smallest number in second row is 3, and the smallest number in third row is 12. Okay, same. Now for row we have to consider the minimum, and for column we have to consider the maximum. So let's say we have maximum in first column is 15, maximum in second column is 16, maximum in third column is 17, and maximum in 12th fourth column is 12th. Okay, now we know these are the minimum values of the row and these are the maximum values of the row. Okay, we know. So like for getting, first of all we have to to know this 12 is minimum in its row and this 12 is maximum in its column. Like for 12 being lucky number, it has to satisfy two conditions, but we need to check whether it is the smallest in its row and it is greater in its column. So okay, so what we can do here is we can find all the smallest all the elements, all the smallest element from each row and store them somewhere. Like okay, we have this two vectors, this is, it stores the smallest from each row and this stores smallest from each column. Okay, so let's say it is store 1, 3 and 12. Okay, so we know that 1, 3 and 12 are the smallest from each row, and then 15, 16, 17 and 12, these are the greatest element from each column. Okay, so we have stored them. Okay, because whenever, because we have to check for two condition. If we are checking for the 17, so this should be smallest in its row, so we should know that for this row what is the smallest element, so this is already present here. Okay, and in the same way, if we are considering this element for happy number, then we should know that it should be greater in its column. Okay, so we should have that check. Like if 17 is there, so what is the greatest element of this column? It is 17 only, so yes, we can say that 17, it is satisfying the first condition, but we also have to check whether it is smallest in its row or not. So we can check whether for third row what is the smallest element. It is 12, it is not 17, so we can say it is not a lucky number. Okay, understood now? Like let's say consider for 12 only. Okay, let's consider for 12 only. So when we are at this I comma j, okay, I comma j, which is like let's say 2 comma 3. Okay, it is 2 comma 3. When we are at this index 2 comma 3, so we will check for this element whether for this element. Okay, what is the smallest for this row? it is 12 only. Okay, so it is good, like first condition is satisfied. Now for this to be lucky number, it has to satisfy one more condition. It should be greater in its column, so we will check in third column what is the greatest element which is there. Okay, so it is also 12, so we can say this is a lucky number. Okay, so understood now, like we will have smallest of each row, okay, stored in our vector, and greater of each column stored in our vector, and for each element we will check whether it is smallest, whether it is equals to the smallest of that row and greater of that row. If it is satisfying both the condition, we can say that it is a lucky number and we can add it into our result. Okay, so I think the approach to solve this question in the question is critical. Now let's quickly jump to the solution. So let's first of all, we have vector of int, let's say it contain row is smallest number. Okay, then vector int of column. Okay, let's say we define row and column, not row min, and call max. Okay, now let's have size of its int row is equals to matrix matrix dot size, then int column is equals to matrix matrix 0 dot size. Okay, so we have row, or we can define them as, okay, so let's say it is having row minimum is of size row and having int max as value. Okay, and column it is having size as col and int minimum as its default value. Okay, now for we will iterate in the matrix for int I is equals to 0, I is less than row I plus plus, then for int I j is equals to 0, j is less than col j plus plus. Okay, what we will do, we will check if okay, let's say uh, uh, what, okay, so row min for particular I is equals to minimum of row min comma matrix matrix of I comma j. Okay, and for call max of j is equals to maximum of call max of j, here I will come. Okay, and matrix matrix of I comma j. Okay, so in this way we have find our column minimum and column maximum. Okay, so now for again we have this, we have found this, made this. Now for every element we will check whether it is equals to the minimum of that row and maximum of that column. If it is, we will add into our result. Let's say we make one more vect or vector of int result result. Okay, so for int I is equals to 0, I is less than row I plus plus. Okay, then for int j is equals to 0, j is less than col j plus plus. Okay, now we will check if matrix 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 of I comma j is equals to row of I and matrix matrix of I comma j is equals to row min. It is row min, and it is call max of j. Okay, so if it is equals to the row minimum and column maximum, then we can add into our result. Resu result dot push back met X matrix of I comma j. Okay. Then after this we will return our semicolon. Let's run this. So it is accepted. Now let's submit and try. So yes, it is accepted successfully. So beat 93%. Now for its space and time complexity and space complexity. Time complexity for this particular solution is capital O of n cross m. Okay, because we are iterating two times for row and column. Okay, so and for space complexity it is n plus m. So this is our space and time complexity. So thank you for watching.